right, welcome everyone to this week's Ronin Seminar. This week we got Ruth Duerr, who is going to present to us a talk called From Data to Information. And first she's going to tell us a little bit about herself, and then we will carry on. Please take it away, Ruth.
Okay, great. So my name's Ruth Duerr, and as you're all aware, I'm currently with the Ronin Institute, but I've had a long and interesting career at primarily the University of Arizona, the University of Colorado, and the University of Alaska Fairbanks, where I started off basically looking out at the stars and have, over the course of my career, become further grounded past the sun into the Earth's atmosphere, and then land surface and ocean, and more recently, human beings on the surface of the Earth. And during all of that time, I've been sort of on the techie side of things. Used to be an actual programmer and system engineer for some pretty big systems, and am moderately well known in the field. For example, I'm the current chair of the American Geophysical Union's Earth and Space Science Informatics section. So I've got a group of 4,500 people to keep happy in that area. And I titled this talk From Data to Information because over the course of about 4 stories or so, I sort of wanted to give kind of a historical summary of a lot of the things that have been happening in science, my role in it, and where data is and where information is. And when I was putting this talk together yesterday at about 3:30 in the morning at slide 58, I realized, well, you know, I'd done part 1, 2, and 4 pretty well here. Part 3, that's going to take another 8 hours, and it's 58 slides, so there's no way I'm going to be able to do all of this in one talk. So I apologize to all of you in advance that if you're at all interested in this kind of stuff, the conclusions are in the future. So today, what I really want to do, and I hope to get through in the time we have available, is give my perspective on a history of data and science at the poles, because I think the whole data and science enterprise is pretty well exemplified by what happened at the poles over the last few hundred years. And then I want to talk a little bit about what data is today. And in that case, I will actually give you 3 examples of projects I'm currently working on. They're all funded projects. And then we can think a little bit about what that means for what is data today. And that's probably as far as we're going to get. And hopefully we'll get that far. Okay, so the first thing I'd like to talk about is the International Polar Years. A lot of people don't know that there were International Polar Years going all the way back to 1882, or that the International Geophysical Year in 1957-58 was really the 3rd International Polar Year. And the way that got started was basically that there had been expeditions through the polar regions trying to find, you know, the Northwest Passage for many years, actually a couple hundred years. And each of these expeditions had taken scientific measurements, but they hadn't been done in any sort of consistent way. And so this guy, Carl Weiprecht, basically was upset about the factor that all of these thousands of observations only furnished us with a picture of the extreme effects of the forces of nature in the Arctic regions, but leave us completely in the dark with respect to their causes, which is what he wrote in a paper in 1875 to the Royal Geographic Society. And so he advocated that a more coordinated effort occur with instruments precisely alike, governed by precisely the same instructions, and for a period of 1 year at least, to record a series of the utmost possible synchronous observations. In other words, the idea was to get a series of research stations all around the polar regions, all taking the same kinds of data at the same time of day with the same kind of instruments, so that you could get sort of a global, if you want to call it that, view of what was going on in all sorts of areas. And they did this actually with a wide variety of instruments and study types. So it was multidisciplinary as well as multi-country. Now, the only problem with that was that each of the countries had their own place that the data went, and therefore pulling that data together was rather difficult, and in fact didn't actually happen until 1995, I believe. But it was a reasonably successful program, that very first one, except for the one expedition to Lady Franklin Bay. But even that expedition saved the data, because this was in the day when data was really considered to be the important thing. And, you know, only 6 of the original members of that expedition survived, but the data did. I mean, they actually packed out 150 pounds of data when they were not they pretty much had to walk out, and instead of taking, you know, all of the stuff they probably needed to survive, they took their data. Why? Because they needed to preserve the results of their 2 years of arduous labor. And back then, data was deemed to be the important thing. And it was considered, you know, the reason for going. That's why they did go. And if they had not brought that back, they would have considered, you know, all of those people who did not survive's mission to have been in vain. Now, 50 years later was the second polar year, and I should note that polar years are supposed to come 50 years apart. That was the original plan. And this one was bigger and, quote, better. It had 40 stations. It wasn't just Arctic, but it was also Antarctic. And it used all the, you know, beginning to be modern stuff, like airplanes and, you know, radio. And there was only one problem with it, and that is that there was this small thing called World War II. Well, why was that a problem? Well, having realized that, you know, the problem with World War I, with IPY-1, was that while they had managed to collect all this data, it was done on a country-by-country basis, and there wasn't really any easy way to get all that data together to do the kinds of, you know, global assessment that was the original goal. In fact, that bringing all of that data together did not actually happen until the 1990s. So, so in this version, the International Council of Science, which at that time I think was called the International Council of Science Unions, ICSU, had decided, well, okay, so this time we need to do it better. We need to put all our data in one place so that it can be, you know, analyzed as a whole. And so they agreed to do that. Unfortunately, the place they picked was in Europe. And as a result, a lot of that data is not, doesn't exist anymore. And because of that, because of that, after the war, everybody got together and went, well, IPY2 is kind of a bust. We better do it again and start up our series of every 50-year thing. And so they planned on the International Polar Year, but by then other groups had figured out that it's not just the poles that are important. We should do the whole Earth, and so let's make it the International Geophysical Year. And they were studying pretty much everything. And so they had a slightly better data management plan. In this case, what they did was they formed something called the World Data Center System. And these data centers were meant to be disciplinary. For example, there was a data center, World Data Center for glaciology. In fact, the National Snow and Ice Data Center, where I worked for 14 years, was a World Data Center when I joined it. And they generally, each of those data centers, disciplinary data centers, generally had 3 copies of themselves. And those copies were distributed across the globe. For example, NSIDC was the World Data Center A for glaciology, whereas Data Center B for glaciology was in England, and Data Center C for glaciology was in China. And so the point was so that each of those data centers were supposed to have basically a copy of all the glaciological data. In other words, globally distributed backups of the data, so that if any one country had issues, the data would still remain. And that was great. And I should note that that lasted for a long time. In fact, when I was at NSIDC, China was still actively trying to scrape our NSIDC's websites and data holdings so that they could have a complete copy. That was all the way up to about 2006, I think. But the problem was that there was never any international mechanism to provide funding for those data centers. And so they were funded by their hosting countries. And while for a while that seemed like a politically good thing to do, and some countries did that well, that generally did not last very well. And so, as has been traditional, I guess, with data for a long time, funding became a problem. And so, just keeping copies of what was going on in other places became difficult, especially as the size of the data grew exponentially, especially with digital data. And part of this was, that all data was supposed to be available to anybody, anywhere, at the cost of duplication, whatever that meant. In the past, that might have been mimeograph or Xeroxes or whatever. Later on, it might be, a cost of a CD or DVD. But the point is all the data was supposed to be publicly available globally. And if this sounds familiar to what people are trying to do now, maybe that's the point. So, moving on. What was that data back then? Well, it was basically technical reports, publications, and journal articles and things like that. In the next slide or two, there are some pictures of the NSIDC library and archive, which is just chock full of these things. Books that have 15 pages worth of description of how the measurements were taken and where they were taken and all that other stuff that nowadays would be called metadata. And then it would be followed by a few hundred pages or more of either charts or tables with numbers, with nice headers and things of that nature. Even back for a long time, even a lot of fields had special journals that did data. And so the paper you see in the middle, probably can't read anything at all, but it has little, what looks like stars with numbers next to them, is a paper I wrote in like 1982 in the Journal of the Publications of the Astronomical Society of the Pacific, which was a journal that was used to publish data. That was its purpose back then. And that was pretty common up through the beginning of the digital era. And I should say that I was doing astronomy right at the death of the photographic plate. And in fact, I was still doing half the work I was doing then on photographic plates. And that's a picture of one of them. And that's the way they published their data. And it was expected that you would publish your data. All of the astronomical observatories had a, quote, library full of data. And if you go to NSIDC, it has an archive and resource center, which is the World Data Center, which, you know, is basically full of these big books that I was talking about, you know, that are all the data from the International Polar Year number 3, the International Geophysical Year, or even older data going back to the first International Polar Year or even preceding that. And so that's the form the data took. And that's pictures of what it looks like now. I'm showing up in the upper right-hand corner a comparison of the same glacier over about 100-year difference. And the reason why, you know, you can do those kind of comparisons is that the glaciologists way back then realized that to get, you know, mass balance and figure out what was happening in long term, they needed to have recorded really well where they were taking photos of glaciers. And they even did things like put little everybody's probably seen a USGS location marker, which is a big, you know, stake you more or less put into a rock, you know, in a place that, you know, it's not going to move. And so glaciologists today, particularly Bruce Molnia from NOAA, have been going back to those very same spots and retaking those pictures, because with these kinds of pictures, you can actually, you know, do a lot to determine, you know, how much ice has been lost and that sort of thing. So what I'm saying is that places, the world data centers, all started off as libraries and archives, and all eventually had to become sort of digitally focused. And so then the question is, you know, what does that mean for the future? So, and we just had the last of the IPOIs so far, 2007, 2008, and it is even bigger than the International Geophysical Year was. These are all the projects in it. And you can see that it covers all the different fields you can possibly imagine. And it's not just, you know, it includes people, education, outreach, everything you can think of. And it involved about 50,000 people. Meanwhile, the old World Data Center system, which had become not well funded, and all of those data centers lost their ability to clone each other, basically became defunct. And so the International Council of Science recently has tried to revive them and reconstitute them by a world data system, you know, replacing the world data centers with repositories that are trying to federate themselves into a world data system. But they have the same fundamental problem, which is there's no global funding mechanism, and funding for keeping science data going, it's hard to come by. And so the message there is that of all of these, only about only a few of them, only a little of that data is really globally available. Most of it's not. And personally, I think that's sad. So that's the first story, the history of data in the polls. And it's a story that I think is all about increasingly greater scientific ambitions and some initial understanding of the importance of data in both the short and long term, and a total lack of ability to do anything about it or good with it. So that was story number one. This next story will be very short, I hope. So now I want to talk about what is data today. And I'm going to do that as 3 examples of my own projects. But first I have to give you a very, very, very short overview of this thing called a semantic resource. This is just a graph showing that there's many kinds of semantic resources out there. They're all useful for different things, from simple taxonomies and controlled vocabularies to thesauruses and conceptual models and OWL things. And you don't need to know any of those other than that, you know, that's what a semantic resource is, which I'm going to be talking a lot about. So the first project I want to talk about is Clear Earth, and that's an NSF-funded project to bring semantic technologies and semantic resources from the biomedical field into the Earth's surface, Earth, ice, and life sciences fields. And the reason why is because biomedicine has had a lot of money to put into this for a long time. And so compared to everybody else, they're very advanced in building these sorts of deep semantic resources that are needed and useful for natural language processing, machine learning, and that sort of stuff. And so the goal of this project is to adapt those techniques to earth science to facilitate interdisciplinary discovery and access. And we'll probably in the next talk about why that's important to discovery and access. Interesting. I seem to have missed a slide here. Same slides twice, huh? Interesting. Okay. So if you're talking about natural language processing, machine learning, what they now call deep learning, the interesting thing is that, you know, any of these technologies have been really require supervision. In other words, humans to make them successful. In other words, it's supervised learning. And then if you don't do that, it's very easy to actually confuse these algorithms. The example here is very slight, invisible to the human eye, differences in an image might turn a dog into an ostrich as far as a computer is concerned. And so, you know, it's all pretty superficial at this point. And the key to the success of any of these technologies so far is that they require data, input data. And so, you know, when you're doing these kind of projects, you have to have data, and, you know, you need to know what data is needed. Do you need to collect more of it? Do you need to label it? And so that's the issue. It turns out that the first thing one has to do if you're porting all of these technologies from biomedicine and newspapers, by the way, to other fields of science is you need to have that data. And so it turns out the most useful thing this project is doing at this point is creating these large corpori of open access journals and various other kinds of text that have been annotated. I'm only showing cryospheric here because Ann Thiessen, another Ronin, is involved for the biology part of this, and you might want to get her to talk about that someday. And Chris Jenkins doing the geology part of this. And so what we have are nice cleaned up corpuses of basically all the text in these 2 open access journals. then various annotated versions of that for named entity recognition and all sorts of things of that type, which are useful then for doing analyses of text. And part of the reason for that project is to move up that graph that I started off showing you with, to moving to the upper right hand corner towards formal ontologies, so that at some point you would be able to talk about and automatically generate ontologies that would understand things like carnivore as a subtype of heterotroph, or population as part of a community, or net productivity as a quality of an ecosystem. So that's the point of that one. So that's the first project. The second project is called Polar Insights. And its premise is more that, data is highly distributed and diverse, and even just finding out all that there is of it is more or less impossible. And so what if we just try and build a Google for data for it, through focus crawling? And so that's that project. And our goal here is to do that focus crawling for the polar regions and make it possible to query, everything there is to know about a domain, and use the kind of tools that were being developed in the Clear Earth project to find the appropriate data and documentation, evaluate what you found, and allow exploration of it. And somehow these slides have gotten really screwed up, but hey, whatever. And so this is the architecture of it. It's not really important for you to understand that architecture, other than to know that it's got a few steps, and that everywhere involved in those steps are those kinds of semantic resources that that the other project is creating. And that you can actually then use tools to mine the world, really. And so this is an example of a tool. Yeah, I'm sorry, programmers sometimes don't make wise choices. And in this bigger case, why they chose to say that that pink was good because you love it, I don't know. But this is one of your, should be stoplight colors, and they are, but they're in the wrong order, where basically you can train a crawler to crawl whatever kind of thing you want. In this particular case, you're training a crawler to crawl for ocean best practices. It goes out and gets a bunch of things it thinks are best practices, and then it tells you how good it thinks that is, and then you update it. And your goal is to get it to the point where every time it goes and gets a new batch, all of the colors are right. And yeah, I'm sorry about red being good, green being and orange being really bad. But once you're done doing that, then you basically update the model, let your crawler run, and you go off and get a bunch of data that matches what you wanted pretty well. And we've been doing some work in trying to, then build tools that allow you to assess what you've gotten back. And here's some very simple examples of that, distribution of documents by date from a crawl that we did for polar stuff, and then distribution of documents that are mentioning icebergs. And then you can wonder, well, what's going on in 2005, 7, and 12? Why were those popular years for mentions of icebergs? And you can even do more complicated things like, well, for documents that mentioned icebergs and that something was icebound, where did that all happen? And here it seems to be Canada, Alaska, and Norway. So, and then the last project is I belong to an organization called the Earth Science Information Partners, which consists of all the major U.S. agencies, a number of research organizations, individual investigators, commercial companies like Esri, et cetera. And their 20th birthday is this year, and I thought, well, they were collecting video interviews and stories from members, and they managed to get 56 of them, which is pretty good given that the group is probably only 400 or 500 total. And so I thought, because ESIP's always been trying to prove their value to their funders, that, you know, maybe we could mine that data for recurring themes, good quotes, prominent personnel mentions, that kind of thing. And so that's what we're doing. And then you realize that once you've done that kind of mining and a little bit of network analysis, that once you have that kind of a graph of, you know, these people are associated with these kinds of themes, then you can associate that with other kinds of graph information, like, you know, who they authored things with, you know, what NSF grants they had, or even commercial data, you know, social media, what kind of posts do they tend to write, what kind of purchases do they make, where do they travel, etc. Does this sound a little bit, you know, Big Brother-ish, maybe? So you have to think carefully about that kind of thing. So what is data these days? Well, from my projects, you can say that it's text of any sort, videos, audio. I should note that the Polar Insights, one of the things they're doing is, auto captioning photos of cryospheric things, because you can actually start to do that these days. Software of many types, from the full range of semantic resources to various algorithms to Apache projects. We're actually contributing Apache code back to, of course, you know, actual things like specimens. And basically it's every kind of digital anything. So, you know, what is data? Well, it's in the eye of the beholder. So, and that brings us to Weapons of Math Destruction, which is a book I really love. And she's talking about the dangers of a lot of these kinds of technologies and use of data. And I have to say that all of this is very real, and I have to think about it from even my own project's standpoint. And with that, I'm going to quit for the day.
Excellent. Thank you.